Hey there, it's Shannon Matchek-Myers, and we'll start with a little warm-up to help you with section 8.3 trigonometric integrals from our Larson text. So let's go ahead and get started. Simplify the trigonometric expression to a single term. So 1 minus sine squared at x is equal to, beautiful, cosine squared at x. And 1 plus tangent squared at x is, awesome, secant squared at x. 1 minus cosine at 2x all over 2 is actually equal to sine squared at x. That's one of the power reducing formulas. And then 1 plus cosine at 2x over 2 is cosine squared at x. So we often will use them going the other direction, but especially in this lecture, but keep in mind anything with an equal sign goes both directions. Excellent. All right, now complete the statement. If u equals sine at 2x, then du equals, beautiful, 2 times cosine at 2x times dx. If u equals cosine at 4x, then du equals, awesome sauce, negative 4 times sine at 4x times dx. If u equals tangent at x, then du equals, excellent, secant squared at x times dx. And if u is equal to secant at 6x, then du is equal to 6 times secant at 6x times tangent at 6x. Good so far? Awesome. All right, now these are some of the basic integrals we'll end up using. So this one, if you have a sine squared at x dx, sine function is alone and squared, we have to use that power reducing formula. So that's going to be the integral of 1 minus cosine at double the angle, which is 2x in this case, all over 2 times dx. And so in for sine function, we rewrite the sine function as this one, and that came from part C. All right, cool. And then this one will end up being the integral of 1/2 dx minus the integral of, minus 1/2 times the integral of cosine at 2x dx. Now we're going to need a 2 for that angle for our g prime, because g is 2x. And so that means we'll have to multiply by 1/2 on the outside of the integral. And then we will get 1/2 times x minus 1/4 times sine at 2x plus a constant of integration. Good so far? Now that's just going to be a small portion of the problems coming ahead. And then similarly, we would rewrite our cosine squared at x as 1 plus cosine at 2x all over 2 dx. And that is going to be coming from formula D, 1D. And then similarly, we'll get the integral of 1/2 dx plus 1/2 times the integral of cosine 2x dx. Again, we need a times 2 for our g prime, so to balance it, we'll multiply by a half, and then integrating, we'll have 1/2 x plus 1/4 times sine at 2x plus our constant of integration c. Groovy so far? Awesome. And then this one, often so easy it's hard. The antiderivative of the secant squared at x with respect to x is the tangent at x plus your constant of integration. And again, another so easy it's hard one. The antiderivative of secant at x times tangent at x with respect to x is just secant at x plus c. A lot of times these are the ones that students get the most tripped up on in the trigonometric integrals section. All right, so go ahead and take a little break, and we will come back for the first part of 8.3. If you like what I'm doing, go ahead and hit that subscribe button, like the video, and share it if you really like it. And have a wonderful morning, afternoon, or evening. Bye.